Thank you for sticking around for our last session in this theater for the day. What we are going to be doing is actually live streaming this talk. It's part of a series that we do live. We're attempting to do it monthly called Datadog On. It's where we invite the engineers who are actually building our products to talk about the interesting challenges that they are solving and how they went about solving those. So what I'm going to do now is I'm actually going to invite Jason, who's one of our hosts of the Datadog On series, and two folks from our product and engineering org, Othmane and Conor. Please welcome Jason.
Hello, everyone. Thank you for being here. I am Jason Hand, and just welcome to a very special episode of Datadog On. Just real quick, how many of you have ever seen an episode of Datadog On? A few of you out there? Okay. Well, like Jacob mentioned, it's something we do pretty regularly. About every month or so, we stream online, and we bring in a couple of different people from our teams, from our variety of teams that we have within Datadog, and talk about some of the challenges that they've faced and what they've been doing to get around those challenges. And today we're going to be talking about Datadog on LLMs, from chatbots to autonomous agents. So if this is your first time on a Datadog On episode, welcome. For those of you who are watching us on the live stream, welcome. We're happy you're here. So let's just kind of move forward. But before I introduce our guests, I just want to point out that if you would like to go check out any other Datadog On episodes, you can go to datadogon.datadoghq.com. You can go find all the episodes there. We've got a lot of great stuff. And also, I'll add that if you have questions, we'll save some room at the end of this, and we've got some microphones on the sides here in our aisles, so you're welcome to come up and ask questions when we get to that. So, without further ado, I'm going to go ahead and introduce my two guests, so I'll have them come on out. Conor and Othmane, if you'd like to come join us on stage. They can hear us. There we go. Come on out, guys. So I'm going to let both of them introduce themselves real briefly, and then we'll get moving forward. We'll start with you, Conor. Go ahead.
Yeah, hey, I'm Conor. I'm a senior staff engineer at Datadog. I've been working as sort of the Bits tech lead for the last year or so. Don't have much of a background in ML before Bits, so you can do anything if you want to try it. But I worked prior in sort of like data platforms and metrics and things at Datadog.
Cool. Hi, everyone. I'm Othmane. I work with the data science team here at Datadog, essentially building data science, ML, AI-backed products and features within the Datadog platform. And over the past 1 or 2 years, I've been working with various folks, including Conor, on building LLM generative AI-backed features within Datadog.
Excellent. All right. Well, let's just sort of get a little bit of the agenda set so we all know what we're talking about here today. We've got 3 subjects that we're going to explore a little bit here. We're going to start with, there's been this evolution from chatbots to autonomous agents. We're going to talk about how we evaluate those and what kind of techniques are involved with that. We're also going to get into some of the underlying techniques around these models and LLMs when it comes to using RAG or fine-tuning, tuning from scratch, that kind of thing, training. And then last, we'll get into the observability of Gen AI agents before we finish up with some questions. All right, so let's go ahead and I guess get comfortable here with the 3 of us. And how many of you were at the keynote this morning or actually saw the keynote, maybe live streamed or something? All right, so there was a ton of really exciting announcements that we had. One of them, it was the autonomous agents that we got to see towards the end there with Bits AI. I'm wondering, maybe let's start with Conor here on this first question. Maybe you can tell us a little bit more about some of what's going on with these autonomous agents, maybe some of the things that you've run into as you started working on these things. What can you tell us?
Yeah, sure. So just to recap, if you didn't catch the keynote or you didn't get all the details. So essentially, this morning we introduced sort of a new mode to Bits AI, which is working as an autonomous investigator. So essentially, from an alert, it can go through and look at the context and the information associated with that alert, build a plan of things to do, and actually execute that plan using data from Datadog. So it's going to look at logs and traces and metrics and other things. But just to step back, and actually relevant to our title, is sort of how we got here from what we launched last year, which was the Bits chatbot and some incident management features. So the chatbot is really powerful. You have all sorts of capabilities available to you, but it's pretty open-ended. You have a text box, and it's not necessarily clear what capabilities are there and what are not, and also not necessarily the thing you would pull for when you're in an incident or you're responding to an alert, because you may not know which questions you're looking to ask or how to use it essentially in the sort of heat of the moment. On the other hand, the incident feature that we released, the incident summarization, the way that worked is you join an incident and you're given this summary automatically. And what we found is that sort of like proactive summary, something that happens without you necessarily having to ask for it, really got a lot of great reception. And we thought that we could use that as sort of a launching point for how we could take this chatbot capabilities to the next level. So essentially reusing a lot of the tools and interfaces that we built into the Datadog product, but at least initially taking a human out of the loop. So that instead of you having to know to ask for this and that data and then to ask it to get synthesized and all these things, we can map all that to a series of autonomous agents and then surface just the information you want right where you're working. So if you're in an incident, you actually get that message in line that says like, hey, maybe you should check out this thing or maybe you should check out that thing, with the end goal being we get you faster to the root cause or resolving the issue and potentially even suggest helpful actions along the way. So that's sort of the approach we've been taking, and that's how we evolved to what we announced today.
Okay, awesome. And Othmane, maybe we'll turn to you now. When it comes to the development phase of these agents or agent, whatever the case may be, how do you know if it's doing a good job, like if it's doing what we expect it to do during that portion of the development cycle?
Yeah, I think that's probably one of the key questions in building with AI, with ML, with LLM, building with agents. And I think one of the starting points is that technically with these very large, very capable foundation models out there, it's extremely easy to get to like an impressive demo, right? Like you can get an API key, spend a couple of hours putting together like a quick demo that will look impressive. But going from that into like a feature, a product that will generalize, serve customers in a reliable, consistent manner with like a quality of service that you can measure and improve on is extremely challenging. And one way to do that, or a very important way to do that, is through evals. And building evals is hard. Building good quality evals is like extremely hard, right? A good eval is an eval that's essentially comprehensive and as aligned as possible with the product outcomes that you care about. Like in our case, like it doesn't really matter whether we're able to measure our agent or model's ability to solve math problems or like respond to brain teasers. What we care about is assisting our customers in troubleshooting their incidents, optimizing their services, etc. So we want an eval that will be able to capture these kind of signals and ideally also capture gradient signals, right? And what I mean by that is that you want this evaluation framework to give you a way not only to get a sense of how well the agent or model is doing, but also to basically discriminate between different versions with different levels of performance. You don't want your eval framework to be too easy, right? Like if all your different versions of the agent and various different models with different levels of capabilities are all at 100% performance, well, that's pretty much useless. And likewise, if it's like extremely hard and everything is pretty much at 0%, that doesn't tell you much. So more concretely, how did we approach this for like Bits AI or at Datadog? So our starting point is essentially like human baselines or human data. So we have our incident management product, or even internally within Datadog, we're able to observe how our engineers are resolving incidents. We can see them talk through like monitors triggering, like services, getting errors or being in a bad state. And we can essentially follow through their investigation steps, all the assumptions, tools that they've used, conclusions that they reach. We also, after the fact, have access to like postmortems and analysis that they might do after the incidents to understand what the root cause is and how to remediate these kind of issues going forward. So we essentially go from that very high amount of text and structured data, and we essentially extract this kind of like key timeline with like all the important steps, assumptions, tools that were used, conclusions that were reached as humans were essentially resolving that incident. We did this manually internally with a couple of incident commanders and essentially built an LLM auto-labeling pipeline that essentially automates this based on any like incident. And with this, we basically now have this kind of timeline of all the key steps, assumptions, tools, conclusions that were reached. And we go back to the initial trigger that started the investigation, and we essentially trigger the autonomous agent or Bits AI autonomous agent that Conor was talking about, and we look at the essentially audit trail of all it tried and all the conclusions that it reached. And based on all of these things, we're basically able to compare like the human baseline to what the agent did. And we essentially look at it from three perspectives. Like one is whether the agent and the humans have similar reasoning. Do they both think of, oh, let's check errors in service A? Two is essentially the tools that they use, right? Like, do they think of looking at error logs or looking at traces, looking at metrics in order to validate or invalidate that assumption? And finally, we look at the conclusions that like humans or the agents reach, and we're able to essentially compare the two. And this is by design meant to be an extremely challenging like framework, like an evaluation framework that gives you that kind of gradient signals. Our intuition is that human level performance on such an evaluation framework is probably around like 40 to 50%. And the key piece here is that initially we want to use this as a way to evaluate, tune, train our agents, anchoring it in the human behavior. But ultimately what we care the most about is essentially being able to reach the right conclusions, right? Like the assumptions or the tools that are being used is something where maybe the agents will be able to figure out like superhuman ways of doing that. And at the end of the day, we don't care about whether they use like traces or logs or metrics as long as they reach the right conclusion. So everything that I talked about so far is essentially around this approach to being able to qualitatively measure how well the agent is doing, being able to try that across different versions across of the agent, different models. I also want to highlight the fact that this essentially validation framework is only as good as it is able to measure the right product outcomes that you care about. And I wouldn't want to understate the value of qualitative feedback as well, right? Like being able to talk to users, your customers, figure out anecdotes like of where the agent does well, where it doesn't. Vibe check the agent in the model, like look at the results, look at its internal reasoning, the steps that it takes, and essentially calibrate your automated evaluation based on that. And if there is like a divergence between the two, that means that you need to go back to the evaluation framework, iterate on it, and put it in a state where it is able to better capture the kind of value that you are seeking out there, like in production.
Excellent. And I think, it sounds like it's very involved, very complex. Feedback is essential in all that. And I think that kind of leads us well into this next area that I'd like to go into and explore. We'll keep with you, Othmane, on this. Maybe if we talk a little bit beyond just Bits AI and some of the things that Bits currently does, what can you tell us in terms of what techniques are out there that we should be aware of, folks in the audience watching online?
Yes, so maybe coming up to that kind of like initial idea that I started with, like for the previous question around, like getting access to like a foundation model and like starting to build with it. I think the very first step that probably a lot of people in the room or people who have been playing with LLMs or Gen AI agents have tried is essentially just this idea of prompting the model and getting answers out of it. And you have like different levels of complexity in prompt engineering techniques. Like the most basic one, and it's what we call like zero-shot prompting, is basically just asking the question and expecting an answer. And this will give you results. It will tend to potentially behave inconsistently or not give you exactly what you're looking for in terms of responses. And that's where you can basically start adding more examples to your prompt. Like a very common technique is what we call like few-shot prompting, where you essentially give, as part of the question, several pairs of questions and answers, right? Like, so this is a question, this is an answer, this is another question, this is another answer, and here is my new novel question. And the fact that you've introduced within the prompt itself these examples will essentially steer the model towards better behaving for the last question that you're asking it. Going from there, like another key piece is essentially being able to inject additional information that might be coming from external knowledge bases within your prompts, again, to give the model like more information, more context to help it perform that task. And that's usually what we call out there like retrieval-augmented generation, essentially retrieving relevant information based on a specific task or question from an external knowledge base, injecting that within your prompt, and expecting an answer out of it. So there are multiple other techniques and layers like on the prompt engineering space, things like self-consistency, self-critique, self-improvement, etc. But these are literally like I think the key foundations or fundamentals. And you can essentially chain these things in very interesting ways. Like if you think about agents, it's essentially like these various specific techniques that you can push as part of a prompt and also invite the agent to basically decide which additional tools to use, right? Like either leverage other LLMs with different prompts or even just leverage like existing APIs or existing tools, etc. But the key piece here is that everything that I've been talking about so far, you're essentially not modifying the model itself, right? Like the weights of the models are essentially the same. This is essentially like what you call like in-context learning, right? Like you're giving within the context additional information to the model, like at query time or at inference time, and through that, enabling it to give you what you're expecting out of an answer. And this works fairly well, and you can basically push this and get like a lot of value and a lot of useful product and a very interesting performance out of that. But the idea is that this is also something that works extremely well with this kind of like large general purpose, very capable models across a large wide of different use cases. The second like level or like dimension of techniques is essentially more around fine-tuning. Here, think of like 1, 2, 3 specific tasks that you care very strongly about, right? Like something where essentially like the performance, both in terms of like quality of outputs, although in terms of quality of outputs, I think fine-tuning and RAG, and there is a fair amount of research on that, will give you very similar kind of like model performance, but think also about like latency and cost. If you basically have these few use cases that you talk about, you can essentially fine-tune a much smaller model towards giving you performance that will match or even exceed the one of closed source model. Like the intuition there is, like these closed source models are essentially huge, right? Like we think GPT-4 has around like 1.8 trillion parameters. And they can be good at like a very wide number of tasks, right? Thousands and thousands of different tasks. But ultimately for your product and for your use case, what you care the most about is probably like a handful of tasks. And for those, if you have like a high quality instruction data set, you can go to a much smaller model, like usually like a 7 billion to tens of billions of parameters model, and fine-tune it towards giving you what you need in terms of perf. And the idea there is that fine-tuning also scales very well, right? Like it's not like you basically need to have like a whole new model for every single fine-tuning use case. As you're fine-tuning, you're essentially just training these like small adapters that you're adding on top of the model that usually represent less than 1% of the size of the model. So if you have like one or a couple of specific tasks that you care very strongly about, where performance matters, go in with fine-tuning, smaller, leaner model that will give you similar performance, what you get out of prompt engineering with much bigger models. The third dimension there that we're calling retraining, that a bunch of folks out there are also leveraging, is essentially about going to some of essentially these open weights models, like including the big ones, and those were trained on a very large corpus of data that has its own distribution, right? And that distribution might not align with the domains that you care about. So what you could do is essentially take that model and retrain it on a data mix that better aligns with what you care about in terms of domains or use cases. Like a concrete example there is that NVIDIA had this like internal model built on top of Llama that they called ChipNemo. That's essentially, again, like this Llama model that was trained on a very large amount of text data, but retrained on a mix that upsamples data that is relevant for chip design. And such a model will be much more helpful for chip design related questions than like a general purpose model. And another really good example that I like to think of when I'm thinking about retraining is essentially this idea that like a lot of LLMs out there are extremely good about playing chess. They're significantly worse at playing checkers, even if chess is significantly harder than checkers. And that comes from the fact that in their training data, there is a huge amount of text data describing chess strategies, right? You want to make it better at checker? Well, you retrain it on a data set that has more of that context, more of those strategies, and that can lead to a better performance in what you care about in your domain. Lastly, I wanted to talk about training and essentially training from scratch. And this is something that can be fairly costly and that in a lot of cases like won't make sense if you're basically caring about like a text modality where you already have very strong pre-trained models. But training can give you an edge if you care about like modalities that are extremely different from what exists out there in terms of like language or vision. Like the idea here is that if you think, for example, about like time series, which is something that we care very strongly about within Datadog, like the time series data or numeric data, you can encode that as text tokens, but that's a very wasteful representation of the data. So if you have a large amount of differentiated modality and differentiated data, training your own foundation models, like training your own transformers for specific tasks leveraging that data, can make a ton of sense and can give you like a big edge in terms of performance. So one key thing that I want to highlight is, like as you're thinking about things from like prompt engineering, RAG, fine-tuning, retraining, training, you potentially can get like increased performance, but this also comes with an increased cost, both in terms of compute and also in terms of engineering complexity. So it's usually like a really good idea to start with RAG and push that as far as you can towards understanding what's valuable for your customers, for your use case, and progressively moving towards like fine-tuning, retraining, training, depending on your needs, and places where you build enough conviction that, again, you are within those kind of use cases where it makes sense to go further and start fine-tuning, start retraining, start training, and ultimately, you know, like a solution to like agents, autonomous agents, etc., is likely to be kind of like a mix of these different techniques, this kind of society of models that are serving that specific purpose for the autonomous agents.
So it sounds like it's a very iterative process, something that never really stops. You're just kind of always doing this to try to improve things. Conor, I want to come to you and ask what you think. You know, coming from the Bits AI team, what does Bits AI look like under the hood when it comes to some of the things that Othmane's been referring to?
Yeah, sure. So when we started thinking about Bits AI as a sort of autonomous investigator, the approach we took is like think about how, you know, we at Datadog, we have incidents, we have alerts, things like that, how we ourselves solve incidents. And usually it's, you know, following some series of steps, whether that's based on what's actually in the monitor or that just fired, or based on some, you know, attached runbook, or maybe it's just based on the title and some intuition that you have about that service because you've worked on it before, you're familiar with it. And we essentially wanted to try to map all of those, that line of thinking, all of those different strategies into essentially a series of agents. So a series of small agents that could perform certain tasks particularly well. And then theoretically, if you can get all of those components to be very, very good, produce really high quality results, work as if a human were doing it, then you could put all those pieces together and you'd end up with this sort of like brain that can help you resolve issues, resolve incidents. But then there's other inputs too. One of the things that we found pretty early on is Datadog is pretty well positioned because we have a lot of context about your services, whether that's in the service catalog or, you know, documentation or other things that you've hooked into it. So we want to make sure that we provide as much as possible to the LLM so that when it makes a plan, that it is able to do that based on the context of the alert and not just sort of whatever it thinks is the right way to solve alerts generally. Because you could ask it, how do I solve this? And it would come up with a lot of, you know, a lot of text, a lot of information, but it may not actually be relevant to the problem we're trying to solve. So to give a concrete example, we have an agent that's really good at log analysis. So we generate this plan, and let's say one of the steps is to investigate the logs for a given service for some time period. So we can focus in on that specific problem and think about, again, how we would do it as a human. Some of the logs in there are probably noise. Maybe you have an intuition that this is something that's been going on for a while already, and you can just sort of ignore it. But there is in there this sort of needle that you're looking for. So it's not just prompting here. We're also trying to leverage some of the other sort of like statistical analysis stuff that we have available to us at Datadog. So some of like the anomaly detection functionalities and other things that Othmane and team have built. So putting all those pieces together, what we're able to get out of one of these agents is an answer that's meaningful, that has context behind it, and that can help drive forward this investigation. So if, for example, that log tool finds an error connecting to some downstream data store, and it determines that that's something new, that's a new error that I hadn't seen before. When we go into sort of the replan phase of the agent, we will use that to infer that, hey, maybe we should dig into that database, just like what you as a human would do. And we sort of continue in this loop until we eventually get to a place where we either hit a dead end and we go back, or we found something that we think is interesting and worth surfacing to you. And that's really key, because we know that this is going to interject in the middle of your alert response or your incident, and we really don't want to be like a worse version of Clippy that's just piping in for no reason. So we spend a lot of time making sure that that final result there is sort of high quality. In terms of techniques, really, a lot of this is just using the sort of basic retrieval-augmented generation, where we're pulling some Datadog data. We're usually doing some pre-processing on it, with some of those anomaly detections, things like that. But we're putting that into the prompt, and we're getting summarization and stuff. And then, of course, in the prompt, we want to make sure we have that other knowledge context to provide sort of grounding for what this information actually means. But then there are certain tasks that we found over time where we think we have like high conviction that it's something we're going to be needing to do a lot at extremely high quality and as fast as possible. So quality, of course, is paramount, but for the problem we're trying to solve, we want to get there faster than you. We want to beat the human to the investigation so that we're actually helping you and you're not just getting there on your own. So specifically, we've looked at query translation, and query translation generally as a place where we can fine-tune that specific task. Because we know, as Othmane has mentioned, this is a task that's very specific, and then we can give a lot of examples to, and then that particular area will be fast. And over time, as we have more conviction on different parts of the agent, we can fine-tune or potentially train or whatever we need to do to make those areas better. And then, again, all these pieces sort of fit together to build the sort of brain of the SRE agent that can actually resolve these issues automatically, hopefully. That's the goal.
Yeah, exactly. Okay, well, real quick, I want to take just a quick poll of the audience. How many of you are experimenting or thinking about experimenting, putting some sort of Gen AI into your services or into your production services? Okay, a fair amount of you. Anybody scared about that? A little bit, okay. Well, let's jump into the next thing here. Previously, we talked about the evaluation of agents and the LLMs and all the kind of stuff that's going on behind the scenes. But I'm wondering, and this is back to you, Conor, how do we sort of observe what's going on with these things as we're developing them, as they're sort of coming along, making sure that things are working as expected, specifically with Bits AI?
Yeah, so I mean, the easy answer is we use Datadog a lot, of course. That makes sense, right? But really, fundamentally, there's the core things that you think about when you're observing a service that, of course, apply here. It's a number of services that are interacting in some way. You want to make sure you have good coverage of logs, metrics, traces, things like that. Essentially, good coverage of core telemetry to make sure the system's actually behaving well. But beyond that, we also want to make sure that among that telemetry, we have as much context as possible to essentially to be able to like replay the state. We found early on, especially with the chatbot, is someone would have some odd behavior, they would get some unusual response, and there's all sorts of parameters that you're putting into your calls to your model, like things like temperature and tokens and all that information. So we want to make sure that that's all captured effectively so that when we see these issues crop up, we're able to actually replay and then eventually put that into some sort of evaluation framework, and we know that we fixed it. The other thing that we think about a lot, both from the chatbot side and as we've moved into the agents, is our token usage. So we really want to be smart about optimizing how many tokens we're using and where, and some of the stuff I mentioned earlier where we sort of do like compression of the data that we're putting into the prompt, like pre-processing or aggregation, things like that. That definitely helps. The other thing we can do is just think about like how precise you need to be in your prompts and how much text you need and what's not needed, and try different strategies. So really, it's important that you have a good evaluation strategy. But then the other side of token usage is cost. And especially when you get into the world of agents where you have all sorts of back and forth with these big models, that can add up really quickly. And LLMs are really, really good at coming up with more and more words and more tokens to spend. So it's really important that early on we had good guardrails in place around our overall costs to ensure that there couldn't get into some like bad loop of planning, replanning, and constantly investigating things, but that it knows when it's sort of hit a dead end of an investigation, line of investigation. So keeping tabs on all of that, of course, and putting the guardrails in place. And then the last thing I'll mention, I guess, is if you caught the keynote earlier, you saw some of our LM observability features. So we now have this as a product, and we've been lucky as we've been building bits to partner closely with that team as they're building that out. But a lot of the things in that are coming out of the box are things that are really useful for us. So just having good measurements of like topic relevancy, toxicity, and all this, again, all the sort of like model parameters that we care about, hallucination, of course. All that information has been really powerful as we've iterating on this tool, or on these agents. And it's especially important when you think with agents, there's like sort of all these different layers. So being able to drill into a specific area in a nice, usable way. So the product's been great for that. But, and then the other piece is evaluation. So in a chatbot land, you can think about sort of like an easy way for people to evaluate, which is they come up, thumbs down on the answer, if it's good or bad. But there's also like implicit feedback, or I said evaluation, I meant feedback. Implicit feedback, which is, did they click on the link? Did they follow through and use that information in some way? And we can do the same thing with these sorts of agents. So did someone actually respond to the information that bits surfaced in the channel and act upon it? Did they include it in their post-mortem? That's like a serious win if we can get there. So all that information, being able to make sure that we're collecting that up front, because as we iterate on our prompts, as we iterate on the logic of the agents, everything else, all this information is necessary to know if we're doing better or worse, and just to sort of keep improving the product. And then, as Othmane mentioned, I think the other thing is just sort of talking to customers on the feedback side, like actually having them give us insights of like, did we get to the result that they would have expected? We don't necessarily know their systems, so we have to spend that time to make sure we get the right results.
Okay, that makes sense for while you're building it, developing it. But I'm wondering, Othmane, maybe you can share your thoughts on once it's in production, what do we look at? How do we make sure things are right? We're not having some sort of thing like model drift, stuff like that. Like, what can you share around those?
Yeah, I think drift is definitely like a big challenge. I think the way you can think of this is even in the classic machine learning world. You're essentially collecting a bunch of training data, you're training a model with it, and then you're putting it out there in production. And then once it's running in production, it's serving its purpose, the world and the data around it will evolve, potentially change, and then slowly the model might drift and the performance might decrease compared to what you got when you were kind of like training the model itself. And there are, like techniques to track this, and then once you realize that you potentially have drift, potentially identify the root cause of that and figure out how to retrain the model to get it back to a good state. So this is essentially like something that is challenging, like when you're doing machine learning. It's even more challenging in the world of like LLMs, AI, and agents. And the idea there is that the challenge is even bigger if you're using like closed models, because the idea there is that you don't actually even have access to the weight of the models, like it's essentially behind an API for you. And all of these model providers, they're essentially constantly iterating on their models, probably making them better across the wide variety of use cases that they're being used for, making them more efficient to run as well. And as they're doing that, like the behavior might change and might end up degrading the specific use cases that you're leveraging them for. So the question there is essentially how can you still like observe, monitor the performance across time to be able to like see it when you have these kind of drifts. And everything that I was talking about earlier in terms of eval and having this kind of like eval pipelines, leveraging human ground truth, that's not something that we're only doing like offline when we're developing the agent. It's something that is meant to be run on a consistent basis to constantly validate across time that we're still doing the right things and that things are trending in the right directions. Everything that Conor was talking about as well in terms of like leveraging LLM observability, tracking all of these prompt responses, all of these chains, all of the out-of-the-box metrics that come with that, the specific metrics that you design and that you care about for the various use cases and tools that you have. That's not only like, a point-in-time like measure, that's something that you are tracking across time, on top of which you can basically detect anomalies, drift across time, to identify where something is going wrong. If you identify drift, like the tools that you have depend essentially on the techniques and models that you're using. Coming back to the question of the closed models, like if you're leveraging the closed model and behavior drifts, well, you're prompt engineering your way out of it, right? Like you're iterating on your prompt, figuring out how to adjust that towards getting back into a state where you have the expected behavior. And this ultimately is also something that gives you more of a reason in some cases to leverage open weights models, because in those cases at least, like you know that you have access to the weights. If you're doing an upgrade or an update to them, you're rolling that out yourself. So thinking about the fine-tuning use case for like natural language queries that Conor was talking about, there we're essentially like have access to the model itself. We can more easily control like updates or changes to it. And in those cases, you might have slightly more leverage in terms of like how you're able to control for and correct like drift when it happens out there in production.
Okay, great. Well, as I'm looking at the clock, I realize we do want to save a little bit of time for questions at the end. So maybe in about 60 to 90 seconds or less for each of you, are there any last key takeaways or things you want to share with the audience when they're out there approaching something like what we've been doing?
Yeah, maybe a quick reality check. I think everything that we're talking about today is like extremely exciting. I think we're very much at the frontier of what we're able to do today with like ML and AI like out there. For us to get to a point where we're able to fully deliver on this vision of like autonomous agents and agents like acting on our behalf and assisting us and everything that we're doing, like the limits of feasibility there are still unclear, right? Like to get fully there, we need, and I'm optimistic, I think we will get like significantly better models and significantly better agents and systems, but there are big challenges there. At the end of the day, this is like super exciting because this is work that has the potential to essentially like reshape a lot of things in terms of how we, even like as engineers and data scientists, like work in a day-to-day manner. And I think within Datadog, we're positioned in a unique way for us to be able to execute on this and deliver value like to our customers around that. Again, like we're super excited about the stuff that we're building. But again, I think that a lot of the challenges and opportunities and exciting pieces, I think, are yet to come as we iterate and further improve and further push the boundaries of what this technology is able to achieve.
Great. And Conor, you got any last final thoughts?
Yeah, I mean, I think we've talked about it a ton through this, but just to really hammer it home, I think the biggest learning I've had, especially as we've moved into this agent model, where there's even more and more back and forth with LLMs and even more and more room for error, is evaluation is everything. Really spending the time in thinking both holistically about your sort of end-to-end evaluation, but also the components of it in isolation. I certainly will admit, early days of working with these things, found myself sort of pleading with the LLM, please do not do this, please do this. And that doesn't scale, right? You need like an actual framework to work against to know if you're getting better or worse, and having like a clear set of guidelines of what that looks like. So definitely invest in that so you don't have to plead with the LLM.
You probably won't get a lot of what you're looking for when you take that route. Okay, well, we've got just a few minutes here. First of all, I want to say thank you both for joining us. It's been very impressive and exciting to learn about everything that you're doing, to learn about what Bits AI is up to now in the keynote. I think is really exciting, and to see where that's going, and just so much that's been done in a short amount of time. From the data science team, Bits AI. Thank you for everything you're doing. I feel like we are really at the forefront of a lot of the technology and the things that are happening. Obviously, the conversations. There's people here who want to learn from us. I think sometimes we do feel like we are the ones who have to be a little bit of the adults in the room and guide, not only ourselves and the business, but our customers and what's going on. So thank you for everything that you're doing there. And I think with that, we'll go ahead and just take a few questions with the time that we have. I don't know if there's anybody in the room that has a mobile mic, but we do have some mics on the side here. So if you've got questions, come on up here to the side, and we'll start over here with you.
Hi, thanks for the talk, very interesting. One of the things that I do as part of my job is meet with potential vendors who tell me about their different AI offerings. And I ask them, how good is your system at what it claims to do? And a lot of the time, all they can say is, well, you should try it on your own system, and you can judge the quality in that way. One of the things I really like about classification problems is you can get something very quantified, like an F1 score, something that's easy and defined and quantified. Since y'all are rolling your own evaluation system, can you speak to the challenges with communicating to clients how good your system will be at what it claims to do without having to really go all the way and explain your evaluation system? Like, how do you explain to others how good your system is?
Yeah, I think you're right that classic classification use cases or like supervised use cases are easier to talk about like in terms of performance. Like if you come back to what we were talking about like in terms of eval, I think this essentially can come down to very similar things if you execute well on the eval piece. Like if you come back to what I was talking about in terms of having this human baseline, in terms of, okay, like here are the incidents that happened over the past 2 weeks for a given customer. Here is how they investigated them. Being able to have this kind of simulation mode for the agent where you're able to rerun it based on that. And you can basically get to a point where you're able to essentially estimate like precision, recall, F1 scores for the different dimensions I was talking about. Here is the AI's ability to make the assumptions that your engineers have made. Its ability to leverage the tools that your engineers have leveraged, and ultimately to reach the conclusions that your engineers like have reached as well. Talking to people about like precision, recall, F1 scores along 3 different dimensions, that can be kind of overwhelming. But ultimately, like showing concrete examples of it in like concrete incidents that they've had, that their engineers had to walk through, I think that makes it much easier to basically show like the value that this thing can basically provide customers. So think of this not only as, like high-level numbers, right? Like ultimately, if I tell you, oh, this is like 20, 30, 40%, what does it mean in practice? Well, we can give you a timeline of some of the previous incidents that you've had and partner with you towards seeing what the agent would have given you in practice if it was actually, like responding to the incident alongside your engineers in production while the incident was happening.
Thank you. Got another question over here?
Yeah, hi. I didn't attend this morning's keynote speech, so I'd like to ask whether you have this. Do you have agent that looks at logs, metrics, whatever, right? Sometimes when you have this history of logs, metrics, your chart, you also need someone like you. I need to log on to the system and to check a few commands in order to further confirm or further if whatever that I have is not enough. Do you have some kind of a agent that is actually live query the system while you are debugging, while you are troubleshooting this? Is there some? If you talked about it during this morning, I apologize. I didn't attend.
Yeah, so I can speak to that. So we don't have anything quite like that today that actually is calling out to your system, but that's certainly directionally, I think, where we'd like to go. Minimally, we'd like to be able to collect the information that can help get you to that next step, even if it's, well, we looked at your documentation and we collected this information and it's pointing at this being the next step. We feel like saving that time where you come to the computer, you come to the page and Bits is saying, hey, here's like a summary of what we've already found, and then this would be the thing you would run on our system. That would certainly save you time. And then theoretically, sure, we could get to a place where we're actually executing things, but that's not something we're working on quite yet.
Obviously, this has to do with permission, right? Obviously, you don't want anything to...
Exactly.
They are controlled. But I would imagine this one day under a controlled environment, that's possible. The other question is, let's say I have metrics, I have traces, I have logs. Is it, in your case, one agent doing all 3 things? You will have 3 agents. Do you have a manager of agents working together? Do you have something like that?
Yeah, it's essentially many different agents working together. So like I was talking about with the logs, we have like an agent that's really good at reasoning and understanding log information and using like anomaly detection and other techniques to then expose some information about some given logs. And then we'll have similar for traces and metrics. And then there's sort of this orchestration layer on top of all of that that's pulling that information together and using it to determine sort of how it should continue the investigation.
Thank you for your question. Any other questions? No? Oh, one more? Okay. Yeah, one more over here. We can get this mic. Here we go.
Yeah, I'll go once more. So again, on the whole rolling your own evaluation system, how do you ensure, you touched briefly on the idea that like one of the cool things about LLMs is this ability to find unexpected correlations where a human might otherwise not find it. So how do you ensure that your evaluation system is not biasing your AI towards conventional, obvious correlations and still giving it room to find these unexpected routes that a human might not take?
Yeah, that's a really good question. I think in practice there are like two levels of answer to that. Like the first one is being essentially like outcome focused, right? So as I was trying to say earlier, like ultimately like there might be different paths to reach the same conclusion, right? The conclusion is something that is very much, like grounded in what the actual root causes of a given incident was. So reaching that point is extremely important for us, right? How do you get there is significantly less important, and you're right? Like I think you can imagine that an agent that is able to basically run through thousands of incidents like in the background and might learn path that might be much more optimal than what like us engineers will be able to figure out, like leveraging runbooks and some of our previous experiences with like other incidents. That being said, I think when you are starting like grounding things in like human behavior can be like a good idea. Like it can be a good way to start from paths that you know will lead to good outcomes. And then from there, making sure that you're kind of focusing on your objective, right? And letting the agent, again, figure out what the optimal paths are. And optimal path isn't only about it being novel or not. It's also about like how expensive is it to get there. Like expensive in terms of like time spent, like as Conor was saying. If we're able to basically figure out like 100% of root causes like a day after the incident is resolved, that's pretty much useless, right? Like for users, we want it to be like following that kind of like timing that or the timeline that humans would typically like have as they're resolving incidents. And there's also the question of cost, right? Like you want it to be, as it's been faster, to be efficient in terms of like how it's leveraging like the compute resources or your kind of like models that are behind APIs and things like that. So you basically want to balance out, I think, these two things.
Yep, great. Thanks you. All right, well, I think we're over on time, but thank you so much for joining us today, and thank you, both Conor and Othmane, for being on this exciting session of Datadog On. And thank you for joining us at Dash. I hope you've had a good time, and we'll see you next time. Thank you.